So now we have our 5 different structures for the sulfate anion. And the question is, which one will formal charge predict to be the best structure? So we need to look at and we need to assign a formal charge to each atom in each of these molecules. So if we look at molecule number 1 over here on the left, we can assign a formal charge to sulfur. It's going to equal the number of valence electrons, sulfur has 6, minus the number of bonds. For structure number 1 over there, sulfur has 4 bonds, minus the number of lone pair electrons around that central atom, there's going to be 0. So this sulfur is going to have a formal charge of +2. Each of the oxygens are going to be exactly the same because they're all singly bonded. Each oxygen has 6 electrons, minus the number of bonds, there's going to be 1 of them, minus the number of lone pair electrons, there's going to be 6 on each of those. So each oxygen in this particular case is going to have a -1 formal charge. Okay? So in order to compare these, we have to write out the formal charges for every atom in all of the molecules. So in the second case here, our sulfur is going to look a little bit different than it did in molecule number 1. Here, our sulfur still has 6 valence electrons. There's going to be 5 bonds around it, still no lone pairs, and it's going to have a formal charge of +1. For the oxygens, there's 2 different oxygens in this case. There's 3 singly bonded oxygens, which have 6 electrons, minus 1 bond, minus 6 lone pair electrons, to give a formal charge of -1. There's also another oxygen in that compound that has a double bond. There's 6 electrons, minus 2 bonds, minus 4 lone pair electrons, giving us a formal charge of 0. So if we were going to assign formal charges to each of these atoms, the sulfur now has a +1 formal charge, the oxygen with the double bond is going to be 0, and the oxygens with the single bonds are going to be -1. And notice that each of these single bonded oxygens in both molecule number 1 and number 2 have a -1 formal charge. So since we can use the same formula, anytime we see oxygen with a single bond, it's going to have a -1 formal charge. And we note that each of these oxygens with a double bond, there's going to be 6 valence electrons, minus 2 bonds, minus 4 lone pairs. So they're going to have a formal charge of 0. So we can kind of simplify all of these calculations by using this fact, and we can now assign formal charges to all the oxygens with single or double bonds. We do, though, have to calculate the sulfur in each case because none of the sulfur environments are the same. So for molecule number 3, sulfur has 6 valence electrons. There are 1, 2, 3, 4, 5, 6 bonds, and there are 0 lone pairs, which gives a formal charge of 0. For molecule number 4, sulfur again, 6 valence electrons. There are 1, 2, 3, 4, 5, 6, 7 bonds, 0 lone pairs. Sulfur is going to have a formal charge of -1. Molecule number 5, we have sulfur again as the central atom, minus there's 1, 2, 3, 4, 5, 6, 7, 8 bonding electrons, no lone pairs. So this is going to give us a formal charge of -2 for the sulfur. So now we've written out all of these formal charges, we need to predict which structure is going to be the best one. And based on the formal charges, we have a couple rules. We know that the charge on the atom has to be equal to the sum of the formal charge. Okay? We also know that there should be as minimal charge separation as we can, and the negative formal charge should be on the most electronegative atom. So 4 and 5 we can eliminate based on the formal charges not being on the most electronegative atom, because oxygen's more electronegative than sulfur, so therefore it should carry the negative formal charge. So we're going to eliminate 4 and 5 based on that. Number 1 wouldn't be a good candidate because we want minimal charge separation. What that means is that we want to have all the formal charges be as close to the same number as they can. When we do a +1 to a -1, that's not a good charge separation right here. So 1 will not be a good candidate either. This leaves us between molecule number 2 and molecule number 3. In molecule number 2, we have a +1 in the center with 3 -1s, whereas molecule number 3, we have 3 zeros and 2 -1s. Molecule number 3 gives us the best or the most minimal charge separation, so number 2 is not going to be the complex either. So based on formal charge, the structure that we're going to predict would have 2 double bonds around the sulfur. Okay? Now we can also take this and we can draw our resonance structures from here. Because this sulfur can be drawn with a double bond at the top and the bottom, or we could draw our double bonds over here on the right and on the top. These 3 structures that I draw over here are resonance because they have the same energy. Each of them has 2 double bonds and 2 single bonds. And we can kind of, look at this way. Now, one of the things about this is kind of a long way to go about to predict a structure based on formal charge. So what I want to point out is a little shortcut. And we can use this shortcut based on the rules that we know.